All right, well, it looks like we've got another nice spray welding job in the shop right here. And coincidentally, it's another pair of these rotary lobe blowers like we just recently did here in the shop. And the person that reached out to me unknowingly asked me about doing this job and hadn't even seen that I had just done a pair similar to this. But unrelated, it was a coincidence that we got another pair of these in shortly after the other pair that we've already fixed. So when he sent me the email, he was asking me, is this something that I could repair with the spray welding setup? Which, yes, I can. This is a great application for this, as we discussed in the previous job that we just did. The difference between these and the last pair that I did was the last pair were solid cast iron. The lobes were solid, and I believe it was a fully casted piece, if I'm not mistaken, because the shaft ends were actually cast iron whenever I machined them. These units right here were probably cast and then fully machined on the inside and the outside of the lobes there. You can tell that this has all been milled, and finished in some machine. But they have a bore through here with a shaft that's been machined and pressed through there. Now, I've got to get in here on each side of these lobes. Let me just move this one out of the way and show you. So we have an oil groove, or I'm sorry, an oil seal that has cut a groove in it right here, and same on the other side. And this is for both shafts. You have a groove that has been worn in the shaft right there. And that right there is a great way, with the flame spray system, to repair these shafts right here. Now, you could set these up in the press and press these shafts out and do it that way, do the repair and then press them back in, but I don't want to go that route. I don't know how tight these things are pressed in these lobes, and I don't want to cause any kind of other problems that I don't see, causing a cracking or an issue with the lobes here. I'm just going to leave the shafts in there. We're going to go to the lathe and we'll do our prepping to do our spray. There's very minimal amount of spraying that's going to have to be done on these. So I'll have a short little area that's going to be undercut that we will build up. But first thing I'm going to have to do on both of these shafts, though, is remachine the centers. Now you can see right here on this guy, this one has been mushroomed in or flattened out there because someone used a puller to probably pull the tapered coupling off of this right here. Same thing on this one right here as well. They've messed the center up, so this has to be remachined before I can go in the lathe with it. This side right here, I'm not sure if that one's any good or not, so we'll just have to check it. I'm going to set up a steady rest because all these journals should be the same size, and I'll have a steady rest set up that we can put these things in just so that we can get in here and retool the centers on all ends. This end right here looks like somebody has cut that off. I don't know if that was done at the factory that way. I don't see a factory made shaft being just bandsaw cut and pressed in there, but maybe, I don't know why this would have been a bandsaw cut unless it just came that way from the factory. So anyway, we've got to cut a center in this side too. So once we set up on this journal here with the steady rest, we'll be able to just machine a center in there. All right, so that's the job that we're going to get started on the day. I don't plan on doing a full bore how-to flame spray video like I did more of like on the last one, indicating all the steps of getting in here and undercutting. But I am going to show you all the steps along the way. I'm just not going to go into full detail. Just want to get some good, fun shots to share with you of the job, especially of the spraying there. All right, so we're going to go ahead and get started on these guys. Man, it seems like no matter how many times I try to test my mic before I start making a clip, I always end up missing some where I didn't turn it on. So, it's just part of filmmaking, part of making these videos, and I'm going to continue to do that. But, at least I can do some voiceover for you. So what we were talking about here is setting these shafts up and setting the steady rest in the lathe. And I always try to show this with my viewers because I have a lot of requests on how to properly set this. So what we're doing is the shaft is chucked in the 6 jaw, nice and straight on that bearing journal on the opposite side. And I bring the steady rest up, and what you want to do is just very gently bring one of the fingers up one at a time until it just touches, and you can feel it touch. You can feel it transfer through that finger and through that finger knob there. And then when you just touch it, stop, lock it, and then go do the opposite side. So the one on the back there. So once you get both of the bottom fingers adjusted to where you can just barely feel it touching, lock them in, and then you want to bring down the top and do the same thing. You just want it to touch. You don't want to apply a bunch of pressure. This is a friction. It is applying friction to that, so you're going to have a little bit of thermal expansion right there. So you got to be careful about how much pressure you apply to that. Use a little bit of whey lube or anti-seize, any kind of oil. You just need to have a little bit of lubricant there on that to help reduce the friction. All right, we've got our steady rest set to this bearing journal here. And the way that I like to do that, whenever you got a shaft that's running really close like that, I checked it was the thousandths run out, and tighten up the base there, and you run these fingers in, and once you get up close, you just barely move these things. Kind of like I say, like you would a micrometer. Just barely come in, and you can feel it when it touches that. And as soon as you come up and it's just touching, you stop, you go ahead and snug the set screw there, and you do that on both of the bottoms. And then you come down with the top with it running, and same thing till it just touches. That's all you want to do. All right, we've got a little bit of whey oil on there just for some lubrication. And then this center here is good, but we're going to go ahead and touch it up with a center drill right there, okay? I am going to have to open the center hole up a little bit with that center drill. It's because they used a different size than I'm using here. That should be pretty good. We're just going to let it dwell for just a second there, and that should be good. We've got a nice cut center in there now. So this one's done. We'll go ahead and flip it around and start working on the other end. Got the second shaft in there. This is the one that's been bandsawed. So I'm just going to dress that face up with a tool here just to clean it up. Make it look a little bit nicer, and then we'll cut the center in there. It does appear to be stainless the way it's cutting. Okay, we again have the shaft flipped around now, so we're going to be working on the tapered end centers. These are the two that are mushroomed out a little bit, and they're probably going to be off center quite a bit. But I'm going to show you a trick that you can use. This is just an old school machinist trick that was taught to me a long time ago that you can use to help manipulate the tool. The thing you have to remember is if you have a center or a center hole that you're trying to follow in the end of a shaft, this tool right here is going to try to follow that, and it's going to deflect. Now you may not be able to see it with your eye, but an indicator will show that. But sometimes you can see these chucks being forced, you know, around like that. But what you can do is set up any tool. You're just using this right here to push against the chuck. And once you get the center pushed in there to where you know it's cutting, you can come up here with this tool using your cross slide and just very gently apply just ever so slight amount of pressure against the tool to force it over to the side and keep it from trying to walk like this, and it'll force that tool to cut a true center in there. So let's go ahead and start it and see what we're working with here. I'm trying to get my adjustment on the lock right here. I like to keep these, I keep the spindle locked a little bit. All right, that's looking pretty straight right there, but we're gonna go ahead and go with this trick. So we gotta open the center hole up with this center drill. I'm going to get in there to where I know that it's cut the center out. Just keep some oil on it. All right, I'm going to let it dwell for just a second there, back out. And it looks like we've got a center cut in there, so I'm going to go ahead and let's go back in there with this. And then I'm going to come up with the tool. All right, and I'm going to push against it. A little bit of pressure. I'm going to hold it there for a couple of seconds, and then we're going to back it back out. So that should be a pretty close cut center. I'll go ahead and set up the test indicator there, and we'll see what kind of run out we got now. When I get this set up, I'll give you guys a close-up shot with the other camera, because I know you're not going to be able to see this with the glare. Just get it set. When I'm done with it, I've just been using this stuff right here, the super degreaser, to cut that oil and clean it off there. This stuff dries super fast, and it's doesn't have a flash point either that we have to worry about later. All right, last center to cut. Here we go. Got our steady rest snug. This is the worst one right here, but I think we'll be fine just doing like we've been doing and cutting this out. All right, that's looking good. Now I'm going to come back in there with my little push trick. Come into where you just touch, like that. All right, and push it with the cross slide. I'll let it dwell for 2 or 3 seconds there. That's the only time I would ever tell you to let a tool dwell. But that works really good right there. And we'll go ahead and test this one too with a test indicator and make sure. Before we start our undercutting and spraying, I want to go ahead and spray some anti-spatter. I'm going to be using this right here, which is your Weld Aid, Weld Clean Heavy Duty Anti-Spatter. And I'm going to cover both shafts and the lobes. I'm just going to spray the whole thing, let it dry. I'm also going to spray up inside these holes there as well. And this will help prevent some of the dust and overspray from collecting and sticking on there. It should make it so that it'll just wipe out. Now, in the direct areas here on the shaft, like these bearing journals, I'm still going to be using my thick masking compound and brushing that on. And I'm probably going to go ahead and brush some of the thick stuff on right around the edge of these inner bores right here, just because whenever I'm spraying, I'm going to be kind of coming in at an angle like this, and it's going to be going past that and deflecting against the inside of these bores right there. So I want to make sure I don't get a bunch of sticking inside there as well. But to start with, we're going to go ahead and use the Weld Clean and go ahead and just coat the whole thing inside and out really well. All right, just like that. And I'll make sure that I cover the insides really well. We are about ready. We'll go ahead and get one of them and start setting it up. I'm going to do these one at a time. I'm not going to set them up and run 2 at a time like I did on the last job. Okay, I'm getting set up for the first one here, and I'm going to, my lovely assistant Abby is off on business right now and is not going to be here to help me do some video. And so I'm going to do the first one here myself, just set the camera on the tailstock here and show you guys me spraying it, and we'll get it done. And the next one, she'll be here to help me out. But I wanted to point something out here. So this is the groove right here that we're building up. So we got to do our undercut. But what I wanted to point out was the journal right behind it, up here close to the the lobes. This is actually 10 thousandths bigger than this right here. This is 1 3/16. It mics 1.188. But directly behind where that groove is right here, it jumps up another 10 thousandths. So there shouldn't be anything fitting this part of the shaft right here. My plan is I'm going to undercut it just past where the groove is, where it's worn, just past it. So maybe a, I don't know, a 1/16 to an 1/8 of an inch. And then when we turn it, you'll actually see me turn it into that diameter. I don't want to take that all the way back to this face right here, but I want to make sure that we go past the worn area just slightly. So it'll be right about in there, so where the pointer's at, okay? I just want people to be aware of that when we go into it. So you can see I've got my masking here on the shaft. This is the bearing fit, and then up in here, because whenever we're spraying, you know, I'm going to be right about in this direction. The pointer is a good indicator, and it's going to go past it and, you know, be touching those bores in there. The face I'm not concerned about. It should deflect off that, and that should be a matter of just wiping it off. All right, this is where I'm going past the seal groove right there, okay? So that's a good indicator of showing the groove depth right there. I went in 10 thousandths, and you can still see a little bit of a groove there. So it's not a very wide area that we're cleaning up. Another 10 thousandths. And you can see it cleaned it up right there. All right, there's our undercut. Now I'm going to cut a thread pitch across there as well. Taking 2 passes across here, 10 thousandths each. There we go. There's our little thread. So we are ready to spray that sucker now. By the way, I am going to be using my RotoJet attachment this time for this job. I've got it hooked into the airline there. This will help greatly reduce the fumes and the smoke that this puts out. And I got my fume extractor going too. Doing the preheat. There's your bond coat. Here's your build-up coat. Not going to take much. Well beyond what we need right there. You see just how fast that is. Now, did you notice a difference in the smoke between the last time I've shown you how to do this stuff? So that didn't take much at all to build that up. So we'll go ahead and let this cool. I'll get my fan over here and let it cool. We'll go ahead and turn this and make sure everything is cool. Okay, time to start turning. Go ahead and get this side turned and finished here. By the way, it is cooled down. Give it a mic, see where we're at there on size. It built up so fast, it actually put more on there than I like to put. It was like an extra 30 thou. So yeah, we still got 35, 40 thousandths to come off of it. There you can clearly see the undercut area of our buildup. And all of the masking worked great on both sides, keeping it from sticking. And it peeled right off there. All right, right there you can see where I'm actually cutting in to that larger journal that I was telling you about. It's right there. So I wanted to go just past my buildup area, so I'm going to set a 0 stop at that position right there. All right. All right, this is going to be our last cut. I'll take 4/1000ths off of it. All right, there we have it. All we got to do is some polishing now. I left out 1/1000ths larger than the finished size so that we could polish it. Got it all polished in there. I was just showing you this. I'm using this burgundy Scotch-Brite to pretty easily rub the masking out of the bores here. And I can tell that I went heavier than what I should have. There was very, very little overspray inside these bores right there. But this right here will cut it out pretty quick. I'm just going to keep working it like that until I get it all out. And once I do, we're going to flip it around and go ahead and get the other side done. But that journal turned out real nice. Looks good. I've got the opposite side prepped, ready to spray. I went ahead and before I did that, I covered it all down again with the Weld-Aid anti-spatter. Sprayed the whole thing down inside the bores. I'm not going to put the heavy masking inside there. I'm going to go ahead and do this one and see just how well that other anti-spatter is going to work against the sidewalls there if I'm spraying in. I think it's going to be just fine. So we'll see on this one if I can simply just wipe it out. So that one is undercut, threaded, and we are ready to spray it.
Off.
I really like that much better with the RotoJet attachment on it. That air that it's pushing through there really helps to eliminate a bunch of that smoke and extra dust. And that little bit of spraying I did right up next to those lobes, there's no overspray in there. I mean, you see a little bit on the face, but that's going to wipe off. And the camera can be a little deceiving sometimes. People generally see a video and they're looking through the flame and they're looking what's on the back side of the flame, and they think that just because that flame is up here in front of it, that this is all getting preheated and hotted up and everything like that. That's usually what people say about the chuck. Like, why are you spraying your chuck? Well, I'm not spraying that. I'm not spraying this either. I'm focusing that little beam of powder that's coming out directly into that. And what you see is a lot of the extra, the particles, the flux in there with it too as well. So I'll get this thing cooled off and we'll go ahead and turn this one too. All right, shaft's cooled down. Repeat of this side, get it turned to size here. Should have been my final cut right there. Yes, got 1/1000ths. You can see that I didn't touch the existing journal right there. So just get this polished up, cleaned up, this will be done. All right, guys, the first shaft is finished up. This is the second shaft, and as you can see, we've already got it prepped. We've got it the undercut done, so let's go ahead and get the torch fired up and get this one sprayed. Alright, that side is built up. Just let her cool. I'll get the fan on it, let it cool. It usually only takes like less than 10 minutes to cool it down. Build up looks good. Yep. That looks good. Alright, there's the one you just saw. Got the shaft cool there. We're ready to turn it. I'm not going to keep showing the turning because you've already seen that. It's just a repetitive process. What I am going to do is bring you back whenever we get it flipped around, undercut, and ready to spray the other side. I will say that I'm really happy with the RotoJet attachment. I can tell that it's working really well. It helps reduce the smoke and the soot. It also helps provide a better bond of the powder to the base metal. Here's a look at that first side finished up. You see the build up there. Turned out great. Got the shaft all polished up, clean up on that end. Just got to flip it around. We got one more to do right there. Okay, that was our final seal fit that we sprayed and turned, finished up, and it looks good. All of them are on size. I went ahead and polished this in right here. This is where someone has been pulling on that shaft with a pipe wrench, so they had some marred up areas. Went ahead and filed them, polished it, got it looking real good. Cleaned it off good. So this guy is done. We're going to pull it out and give you guys some final words on these and what they're used for. All right, guys, these are all finished up, ready to go. I'm real happy with the way all the journals turned out. They got a good finish. They're all on size and a good solid repair that is going to give them years of trouble-free work out of these blowers right there. I always recommend this process for simple bearing and seal repair fits like that. And I wanted to also show, this was the powder I used. I usually have folks ask, so it was the Eutectic 21022. This is the powder. This is my go-to powder for jobs involving repairs like this, for bearing and seal fits or some kind of general shaft fit. But I always recommend this process over a weld, because if you come in here and you weld this, whether you use a TIG welder, MIG welder, a stick welder, you're going to cause some warpage on these shafts. That intense arc that you're putting on these shafts when you arc weld that is going to make these shafts move and draw. The process that I use with the Pterodyne torch or the Rototec, whichever one, they're both designed to do the same thing. They are specifically designed and engineered for jobs like this, any kind of shaft repair in the lathe. You can do it in the lathe, or you can take it out and put it in a dedicated lathe that you want to spray on. But it's a lathe process is what it's for. And the amount of heat that you put in this, you're never supposed to take this over 600 degrees on any of the jobs for this particular powder. That's why they call it a cold spray process, because of the heat range. They have other processes where you actually use more heat, high velocity systems, but that's not really geared for my type of use around a job shop. But it is a good repair. When you have shafts like this, you do not have to worry about warping them or bending them because of the heat that you're applying to them. And it's a process that I really like doing. It's fun for me, and I always love showing it to you. But I wanted to touch on what these guys are actually used for, because I don't think I had any information when I started the video on what they're actually used for. I don't recall if I said anything, so if I'm repeating that, I apologize. But a viewer of mine, his name is Steve, from the North Carolina area. That's where these come from. They go to a sewage treatment plant, and I'm going to read you. I asked Steve if he could tell me what this particular application is used for. Okay, so I'm going to just read off his email to you. And he says, this is one of 6 blowers used to add air to the holding tanks of a sewer treatment plant to keep the saturated oxygen levels correct. The air is also used to pump fluid from one tank to another, eliminating pump impellers that clog easily. The bacteria used to break down the solids need a consistent level of oxygen to thrive and do their job. At the end of the process, we have clean water. So that right there is another example of what I've always tried to tell you guys that watch my videos, of how much heavy industry is involved with making the world that you know and you live in every day comfortable and work. So a water treatment plant, that's what these are used for, though, you know. So think about how many mechanical things are involved to make that plant operational. Not just that plant. Think about how many there are in every county of the country here, all over the world. All right, I had to pause there for a minute. And I believe what I was talking about was that I always enjoy trying to share with you guys what all is involved with industry to bring you the products that you use every day, and also the industry that is used to make those products every day. In this case, we're talking about a water treatment plant, because you know how we all love our good clean plumbing and being able to flush a toilet and also get clean drinking water, you know. So all those things are important to us. Heavy industry is a big reason all those things happen every day behind the scenes that you don't necessarily ever see or even think about, you know. So anyway, that's going to finish it up. One last thing I'm going to do, I'm going to use my CRC SP350. This is the rust inhibitor that I love using. This is more of a short-term and indoors type of rust inhibitor. And it's great for things like this that you want to coat down. And I'm just going to go ahead and start coating them down here. And what this does, see how it lays down kind of wet, but what it does, it starts drying. And as it starts drying, it leaves the oily residue on the surface there. All right, and it creates a nice little barrier against the humidity and the moisture that tries to collect on it whenever it gets out, you know, into the shipping area, you know, as it's being shipped back to the customer there. So there we go. That's it. I just got to get them boxed up now, but I hope you guys enjoyed this project. And I look forward to having some more cool spray welding videos to bring you in the future. All right, see you guys later.